Welcome to ClueCon Weekly. Join us every Wednesday to learn about the latest cutting-edge developments in the real-time communications industry. ClueCon Weekly is brought to you by FreeSwitch Solutions. Get support and professional services directly from the creators of the FreeSwitch open source project, solving your issues in the most efficient, stable, and scalable way possible. Get the FreeSwitch advantage. Visit freeswitch.com. Also brought to you by ClueCon, the premier technology conference for developers by developers. Join us every summer in Chicago. ClueCon kicks off on Monday with our annual hackathon, The Coder Games, followed by 3 days of technology-rich presentations discussing telecom, WebRTC, and IoT from developers around the world. To learn more, visit ClueCon.com or call 877-74-A-CLUE.
And welcome to ClueCon Weekly. Today is the 20th of June, 2018. And today we're going to be joined by Lorenzo Miniero from, he's going to be talking about Janus. So you guys stand by for that. We're going to welcome Mr. Josh Young for the news. Josh, how are you doing today?
Hey, I'm doing all right. Good afternoon there to the FreeSwitch community. If you have any questions during the call, you can please send your comment to the YouTube chat, the HIP chat, or into the IRC channel, and we will try to answer them toward the end of the call here. So this year, we will be having ClueCon between July 23rd and July 26th. You can register right now at ClueCon.com. So be sure to take advantage of the ClueCon 2018 Summer Fun. Get yourself $100 off on your registration. And we would like to stress that the cutoff for the Great ClueCon discount of the Swiss Hotel is June 30th. So make sure you don't delay. Get that done today. And ClueCon has another great sponsor this year, has joined us here. We'd like to thank Aperion for returning as a sponsor to ClueCon 2018. Aperion is a platform that provides useful communication products to businesses of all types. They deliver reliable pay-per-use services supported by intuitive GUI interfaces and great APIs and amazing customer service support. So we thank Aperion for their support. And we would like to thank SignalWire for sponsoring ClueCon this year. SignalWire is a cloud gateway that unleashes so many powerful features in FreeSwitch. You can check out the press release and call for beta testers on signalwire.com. Also, we are really excited to announce our Wednesday evening event, SignalWire Rollout Party. Enjoy bowling, beverages, and bites to celebrate the launch of the distributive new cloud communication platform. And don't miss Food Fun festivities featured by FlowRoute and FreeSwitch on Monday night. You can RSVP for this event when you register. And we will also be bringing back the boat tour sponsored by VoiceTel this year. Last year we had a wonderful time cruising up and down the river and onto the lake for some fantastic views of the city. So you definitely don't want to miss the boat cruise there. Make sure you reserve your space when you register. And as usual, be sure to like us on Facebook, follow us on Twitter, subscribe to our YouTube channel, and sign up for our mailing list to get these and even more fantastic news and announcements. Back to you, Ken.
All right. Thank you, Josh. So we're going to welcome Mr. Michael Malverudas and Mr. Michael Jarris with Community Corner. Hey, guys, how y'all doing?
Good. So today we have a question, which is actually a very good one. It comes from Artem Cherniterzov, and it's from the mailing list. And Mike, this question is for you.
Awesome.
We get a normal circuit congestion error when trying to perform 1,000 simultaneous calls, and only 40 simultaneous calls actually go through. All of the other fail with normal circuit congestion. We have a 1 gigabit link. All default RTP ports are open, and in switch.conf.xml, we've set sessions per second to 1,000. Most FreeSwitch and gateway configs have been left as default. We run a dedicated server. Our provider tells us that 500 lines are available. Is it possible that we miss some config setting that could limit the gateway or channels? Or is it definitely a provider issue?
All right, so just to start out, I think you were going down the right path, double checking the sessions per second limit. The other setting to check would be the total limit of sessions, which is also in switch.conf. As it turns out, we do not ever set the normal circuit congestion error message. That's not what we use for those session limits. So in this case, it's not going to be from that. The only place that that specific error message would be coming from would be from the provider. And the way that you can verify that and to be able to show the provider is if you enable SIP trace, you should be seeing the call rejections coming from the provider in their responses. And it's going to have like a Q850 cause code line in those rejection messages from the provider with the normal circuit congestion error message. I did just go and double check in the FreeSwitch source code base if there's any place we set normal circuit congestion, and the only places where that's ever set are in like the TDM endpoints, like in mod free TDM. So if these are SIP calls, those errors are not coming from us, and a SIP trace will help show the provider that they are indeed coming from them. There's all kinds of things that could be sending that from the provider. But I think you're on the right path of double checking all the session limits. If you pull a FreeSwitch debug log with the SIP traces, you should be able to see that the response coming from the remote end has that normal circuit congestion in the response line itself in the cause header.
So if the call hit the base of the pirate dial plan, what actual response code do we get? We get like a 480, right? By default, because they haven't changed anything?
If it hits, like if it runs out of things to do in the dial plan, or... So there's a few different things that I would look for. If you have some calls working and others not, I think the session limits, the sessions per second and the total session limits are the right first place to look. There's some other configuration for min idle, which also can produce similar errors. It's not normal circuit congestion. I'd have to look up exactly which cause code we use in that case. But those are the general limits that we put in place, and the other things you could be running into is something like mod limit, or a logic error in your dial plan where it's just falling off the end. In those cases, we do 480, normal temporary failure of those. So there's all kinds of different failure cases. What I generally tell people to do is, particularly in SIP, turn on your SIP trace, and also turn on the debug messages. And the debug messages can be kind of hard to parse sometimes, but the way I approach it is I basically look, as the calls fail, you look for kind of the first set of debug messages for the hangup itself, and that'll lead you back to what's actually causing it. In this case, you're going to see a debug message from Mod Sophia for our invite, where we process the response to invite, where we're actually getting the failure coming in, and that'll call hangup. So if you find one call, the logs for one call for that, filter by that UUID, you should be able to see that rejection.
And so what I've always found what makes things a lot easier too is to slowly move down the, so start with warning, and then move all the way to debug. Because debug, there's just so much information in there.
Yep. Debug can be overwhelming, but the upside is the information's definitely there in the debug. In this case, the SIP trace will help you see it as well.
Okay, well, thank you, Mike.
Yep, no problem.
And now we have Lorenzo. So thank you for coming in today, Lorenzo. How's it,
Hey, Michael.
how's it going?
Oh, everything's fine, and thank you for having me. By the way, we've met several times at different events in these past few years, but we never got the chance to actually talk with each other about things that we are doing and so on. So I'm really glad about this opportunity to do it today.
Well, thank you for coming in. And one of the things I was going to say is me, you, and Mike Jarris, we're all going to be at ComCon next week.
Yeah, we will, in the nice English countryside.
Yeah, you guys are doing presentations, and I'm just there to hang out and enjoy life a little bit.
Yeah, I'm really excited about that as well, because it looks like a really huge event, and Jenkins did a really good job bringing a lot of good speakers there. So it's really going to be an amazing event for speakers and for attendees as well.
So what do you have for us today?
Yeah, I wanted to give a quick overview of what Janus is mostly. So I'm not sure how many people that are actually FreeSwitch users know what Janus is and what Janus can do in terms of WebRTC functionality. And so I thought about giving a quick introduction of how Janus works from a high-level perspective. So a few words about the protocol, the architecture, and the different functionality that it provides. And to finally also come to the point of describing some joint efforts that a few users have done to actually get Janus and FreeSwitch to work together. Because as I'll explain later, they actually complement each other in some of the functionality, which is something that I felt really happy about. Because when we first started working on Janus, we wanted to implement something that didn't try to do everything and so on, but tried to let's say, mostly enable functionality that other tools provide. So I don't know if you can put my slides on so that I can show something.
We lose your slides?
Yeah,
let's see. Yeah, I think we lost your slides there for a minute, Lorenzo.
Do you need me to show them again?
Yeah, go ahead and kill the screen share and restart them, please.
Okay. Are you getting it now?
So Janus wasn't your first project. You wrote some libraries before, right?
Yeah, and before working on Janus, I've been working in the field of RTC for a while. So at the beginning, I worked a lot on Asterisk. So I wrote the first Opus implementation for Asterisk at the time. I also worked a lot in the IETF specification. So I wrote a media server that was based on the so-called media control specification at the time, and I've done some other things. But Janus was the first really big project that we brought to the open source community. So, and by the way, I'm noticing right now that I wrote the wrong date on the slide. So that's always a good way to start. And just to give you a quick overview, these are a few links that you can have a look at if you're interested in checking out Janus. So it's basically what we call the general purpose open source WebRTC server. And I'll try to explain later on what general purpose is, because of course it doesn't mean that it can do everything really, but it tries to allow you to do as much as possible as far as WebRTC is concerned. And you can find there a link to the GitHub project where all the code is, a link to some demos that we provide online, which are basically the same demos that you can also get from the repository itself if you install them locally, some documentation that we generate on the fly via Doxygen, and the community as well. So that Google group is the group where we have all discussions related to Janus itself. And the architecture, we implemented Janus in a modular fashion. So the idea was to try to have a core that implemented the WebRTC stack itself, because as you know, because you had to take care of this as well, WebRTC is a huge beast. So a lot of protocols that you have to take care of, a lot of problems that you have to worry about, and so on, a lot of protocols to take care of. And so we wanted to implement this only once and then only worry about additional functionality and so on as different modules and so on, pretty much as you did as well in your project. So in our core, all the JSAP, SDP, IS, SRTP, data channel functionality, for what concerns the WebRTC termination, is in the core. And then we have different plugins to actually expose, first of all, the Janus API over different transports. And by Janus API, I mean a JSON-based protocol that in our architecture is the only way to actually control a Janus instance and communicate with the different functionality that it provides. And we have different transports over which you can carry this protocol for the moment. So you can use it, of course, over HTTP and WebSockets if you want to communicate with Janus from a browser, for instance. But we also provide several different alternatives if you want to control Janus from the server side instead, using different transports. And of course, you can implement new modules and so on to implement new transports for the Janus API as well. But of course, the modular architecture is also enforced for the media management as well, meaning that we have different plugins that implement the media functionality. And the way this process usually works, and I'll try to explain this in a graphical way in a few minutes, is that typically Janus users attach to Janus via the Janus core using the Janus API, as I was saying, and then through the Janus API, they can connect to the plugins that sit on the server side so that they can take advantage of their individual functionality. Which means that the idea is that the core terminates all the WebRTC stuff, and then the plugins can just work on plain RTP and RTCP data so that you can do pretty much whatever you need to do in there. So if one of the available plugins doesn't do what you need it to do, you can either extend them or write new plugins to do the job for you, basically. And the idea then is to have all of these plugins not to be seen as individual applications, so let's say the conferencing application, the streaming application, or whatever, but just as different bricks that you can combine together in order to implement a more complex application. And I'll also try to explain this with a few examples in a minute. And for what concerns the communication and the API, it's typically quite simple because, as I was saying, we have a JSON-based protocol by which users can communicate with the Janus core. Over this Janus API, you can connect to multiple plugins and so on. And then over these plugin connections, you can also establish multiple different peer connections with them. And it can be all peer connections towards the same plugin over multiple plugins and so on. It really depends on which functionality you want to take advantage of. The idea is that you have, as far as the user is concerned, different streams over which you can either send or receive media or both. And then in the background, they are actually handled in different ways. So for instance, in this slide that you see over here, the red peer connection is being handled to communicate to the legacy protocol that may be SIP or H223 or something else, while the green plugin, the green peer connection is being handled locally to do something else. And of course, in order for this to work, in order for this to also be extensible as we wanted it to be, the Janus API needed to be extensible as well, which means that when I mean that we have different plugins sitting on the server side, I meant that these plugins also implement a sub-protocol of their own. So anytime that you connect to a specific plugin, let's say the video room plugin for the SFU functionality, as soon as you connect to that plugin, you start talking to this plugin directly using the language that it exposes. Which means that then you use the Janus API itself as a transport for the communication with the plugins. Which also means, of course, that as soon as you start implementing a new plugin with new functionality and so on, you can also implement your own protocol to handle all the plugin state, all the resource management that you need to do there, which means that it then becomes easily extensible to do pretty much whatever you want. And just to give you a quick overview of some of the most commonly used plugins that we ship, one of those is the so-called SIP plugin, which is basically a SIP gateway. So in this case, SIP is not used as it would be used, for instance, in FreeSwitch or Asterisk and so on. So as a different means to connect to the functionality that the PBX provides. But in this case, we are just providing a gateway functionality. So the user still needs to use the Janus API in order to communicate with Janus. So even when talking to the SIP plugin, you are still using JSON objects in order to start calls and do whatever you need to do. And then on the server side, the SIP plugin creates a SIP stack on your behalf, so that then Anytime that you want to call something, this will be translated to a zip call on the server side, to the zip infrastructure, a zip register, and so on and so forth. The plugin handles incoming calls for you and notifies you, and so on. So this means that this plugin only implements a zip endpoint and not really a zip proxy or a zip server that actually takes care of the zip infrastructure on its own. It's basically just a very simple enabler for zip infrastructures. If you don't want to touch anything on the zip side and you want to keep its legacy on that side, so just plain as zip or maybe SDS, SRTP, or nothing more than that. And interestingly enough, for the zip plugin, we are using exactly the same stack that you guys are using and actually maintaining, which is the Sophia zip stack, even though we also have a different plugin that is based on the RE library instead. And we also have a plugin that is called the RTP Broadcaster, the streaming plugin. And this was one of the first plugins that we actually started working on because it was one of the use cases that we were mostly interested on. So basically having heterogeneous sources sitting on the server side, which might be an FFmpeg script or GStreamer pipeline, VLC, an RTSP camera, or a different Janus instance or whatever, that pushes plain RTP towards Janus, and this plain RTP becomes a broadcast that other people can subscribe to. And this is quite a really effective and nice plugin that we use actually a lot in our own deployments, because it makes it really easy to capture a stream on the server side using something that doesn't need to be WebRTC compliant at all, but then is turned into something that can be consumed by many WebRTC viewers on the WebRTC side instead. And we're actually using it a lot for scalability purposes, as I'll explain in a minute. Then we have the audio NCU is basically just a very simple audio conferencing application, again, just meant for WebRTC users. So it sits there, it decodes all of the Opus streams that the different participants are contributing in the room, mixes them according to some logic and so on, and then returns the mixed audio for all of the participants. So just the basic audio MCU that you are implementing as well in FreeSwitch, but just for WebRTC participants. And finally, this is probably the most commonly used plugin in Janus in general, is the video SFU plugin that is called the Video Room plugin in Janus, which basically allows you to implement the so-called SFU. So rather than mixing all streams into a single video stream, as we are doing, for instance, in this call, the idea is that you publish your contribution and then you receive the contributions of other participants as separate streams. So there is no mixing happening on the server side, but media is just relayed exactly as it is through Janus to the other participants. And of course, there are pros and cons in whether to use a video MCU or a video SFU, but we went with the video SFU functionality in Janus just because it made more sense for us at the time. And we do have a few other plugins in Janus as well, but I'm not going through them all. I just wanted to highlight some of the most commonly used one, also to address some scenarios and some examples in the next few slides. So I was mentioning, for instance, how you can actually combine plugins together. And so how, for instance, the Video Room plugin doesn't need to be seen as the conferencing plugin per se. So, for instance, if we wanted to implement some form of webinar with Janus and its different plugins, we might conceive some sort of a user interface like this, and then we might choose to, let's say, share the screen using the Video SFU plugin, so the Video Room, share the video as well via the Video Room, but then maybe prefer mixed audio instead via either the audio bridge or possibly also even using the zip plugin, because we want, for instance, audio users to be handled by FreeSwitch and mix it there, and then we just connect via zip to a remote audio mixer there. And this also would allow, for instance, for an easy way to inject questions in the conference without affecting the video functionality instead. And at the same time, for instance, instant messaging may be provided using XMPP as a protocol and with some gateway there, or you might choose to use data channels instead via another plugin that we provide that is called Text Room that implements exactly that, so instant messaging for data channels. Another interesting example is the so-called SocialTV example, where, for instance, you have a TV live broadcast, which may be, I don't know, the Super Bowl streamed over WebRTC, while at the same time you have a small conference with your friends, each of us sitting at home and each of us watching the exact same match the Super Bowl at the same time over on the couch, and then when something nice happens, we can rejoice together and stuff like this. And in this case, we might use the streaming plugin for the TV live broadcast, because typically the TV live broadcast will not be originated by WebRTC, but will be captured using different means and then injected on in the background to Janus, and then use instead the video SFU plugin in order to have people communicate with each other. And these are just, let's say, a couple of very simple examples, but maybe it's useful to also have a more practical example, that is one that we actually implement on a regular basis at the IETF, because we're actually the official remote participation tool for all the IETF meetings, which means that 3 times a year we go wherever the IETF is. We configure the whole rooms in order to implement the streaming of the local room and the remote injection, and we actually take care of the remote participation there. And in this specific use case, we're actually using 3 different plugins at the same time. So we are using the C plugin for audio, because all the audio part is handled by Asterisk, which is handling an audio mixing functionality for us. So we just use the C plugin to join the room there. Then we use the streaming plugin to turn static feeds captured via FFmpeg, so a camera that is sitting in the room and the feed that they are capturing from the projector, as plain RTP streams. We send them to Janus, and Janus turns them into a WebRTC broadcast that people can receive. And then we use the SFU to allow remote participation. So anytime that a user wants to present from his home, we just capture his stream via the SFU, and then we distributed it to all the other participants, as well as on a local projector in the room, so that all the people in the room can actually watch the person speaking remotely. And there you can find a couple of slides where I go in more detail about this, because of course I don't have much time to go through all of these now, but just to give you a quick overview of how this all works, this is basically how it all looks like when you join a meeting room. So you actually have no perception that there are actually different plugins that work here. You just see and hear streams that are WebRTC based, and they all look like they are actually WebRTC streams, even though they are not all of them WebRTC streams originally. So for instance, the slides are coming from the projector, as I was saying. The speaker video is also coming from a projector here, while instead this user was presenting remotely from home. So this user was actually captured via the video room plugin. And of course, since these are all video streams, you can play with them and allocate them differently over the UI, considering that this is an SFU, so we can just allocate video differently if we want on the screen, play a bit with layouts and so on and so forth, have multiple remote participants in if we wanted to have that as well. Of course, all of this is also recorded. So in Janus, we record all of the streams individually, and then it's up to the user to actually compose them if they want to do that, in order to have a single video recording, pretty much as in a composition like we are doing right now live. So the way that we do that is that we capture all the streams, we add some metadata to it, and then we convert them ex post using a dedicated post-processor that then takes care of mixing all of the streams accordingly, so that we can then push them on YouTube for fruition later on. And this is also actually useful for us as well, because since we have to monitor and control 8 different rooms at the same time, it's actually very useful for us to have access to all of the streams in real time to check if there is any problem, if webcam stops working, if the slides are not working as expected, if the audio stops working for any reason, and so on. So even this director room that you see over here is actually WebRTC based and communicating with Janus directly in order to consume these different streams. And I was mentioning before how you can actually expand Janus by writing your own plugin or extending them and so on. But as FreeSwitch, all our plugins are actually written in C, because Janus is written in C itself, which means that if you want to actually play with Janus a bit more on the server side, it can be a bit overwhelming if you're not a C developer. Which is why recently we tried to also devote a bit of an effort in order to make it easier for people to write their own plugin in an easier way. And specifically, we recently wrote stub plugins to allow you to implement all the logic in either Lua or JavaScript using duct tape. In the screenshot here, you can see how you can write a simple echo test plugin using Lua, which basically acts as a bridge between the C functionality and Lua. So you control all the callbacks that are fired by the C core there, and you can provide your own instruction accordingly. And it seems to work nicely, and there is actually somebody using all of this code in production, which was really satisfying for us. And another tool that we're actually quite proud of, mostly because it allowed us to do many more things that we thought at the beginning, is the so-called RTP forwarding. So far I mentioned mostly that you can allow different people to communicate via WebRTC, and the plugins basically either just relay the media around or maybe communicate with the legacy protocols using SIP, TSP, and so on. But another nice feature is that we can actually forward the plain RTP that we are receiving from a user exactly as it is to another component on the network, which might be, I don't know, an FFmpeg script sitting somewhere, a GStreamer pipeline, or whatever. And this is actually quite useful because it allows us to basically move all the media processing outside of Janus and do interesting things with the media outside of the context of Janus. Maybe to do live recording instead of the recording as we are doing it now, or maybe passing this to a machine learning framework to actually analyze the media and do interesting things with this and so on. Or maybe, and this is actually the subject of my talk at ComCon next week, implement effectively some form of scalability for Janus itself. So, and I'll explain in a week how this all works, but the idea is that via RTP forwarding, you can feed different Janus instances using a Janus instance as a source, which is actually an interesting feature. And as I was saying, the idea is that there are actually people that are working with Janus and FreeSwitch at the same time, trying to combine these different plugins that you see here with the functionality that FreeSwitch provides itself. And of course, the main functionality, the best functionality that FreeSwitch provides is, of course, the video mixing functionality, which is an excellent tool in your belt, I believe. This is something that works really great, and a lot of people are actually using it in the wild successfully. And so one thing that we note is that some users, I mean, I mentioned how there are some pros and cons in using SFUs and MCUs, but it doesn't mean that you cannot actually use both for your needs, actually. So, and in fact, this is actually what some people are using. So, for instance, at the latest ClueCon, there were a couple of Janus-related presentations that tried to address exactly this kind of scenario. So, for instance, Luca Pradovera from Mojolingo, who is another Italian developer, is, for instance, using Janus and FreeSwitch exactly for this purpose. So to implement some sort of, to still allow people to communicate via SFU if they want to, but then allow people to join, for instance, from the SIP world and so on, and still get the video feed of all the video room participants, even though they are not mixed in Janus itself. And so it's a matter of properly orchestrating how you get people to, how you get the feeds from Janus to FreeSwitch or vice versa. And the good things about standards is that since both FreeSwitch and Janus talk WebRTC, it's really easy for them to exchange media without needing to do anything more than orchestrating the signaling somehow. So orchestrating Verto and the Janus API so that one becomes a participant for the other and vice versa in order to communicate. And another really interesting effort is from Chad Phillips, which I believe is actually a very active contributor to the FreeSwitch community, who is also working on a platform called Moxie, where he's actually trying to do something similar, but also for webinar purposes and so on. So the idea is that you can consume, for instance, a conference, a stream using SFU if you want to, and if you have the capabilities to do that. But if you have limited resources and you can just consume a single video stream and so on, you can just connect to FreeSwitch in order to get a single video that still contains all the video contributions that are also on Janus as separate contributions, which I feel is a really interesting way of combining the different functionality, the different strength points of two really nice open source components in order to implement something that by themselves this component would not be able to do. So this is pretty much all I have as slides. So I guess I can stop sharing slides here and you can have some discussion about all this if you want. So I don't know if you have, first of all, some questions for me on this matter.
There were some questions. And so there was a question from David P, and he actually had two questions. The first one is, do you know of any way to sync a data/text channel with an audio channel?
Yeah, there is no protocol level way of doing that, because with audio and video, it's easy to do that because you just rely on timestamps and you do all the synchronization on that. So that's easy enough. But via data channels, instead, this is not possible because data channels use SCTP as an underlying protocol that has no relation at all with the RTP streams that you have on the other side. And so all you can try to do is implement some sort of, let's say, application level synchronization in the communication that you implement over data channels, but then there is no guarantee that what you send at a specific time will actually get on the other end exactly in sync with audio and so on. So there are some, let's say, hacks that you can do to try and get this to work. But considering that in browsers, for instance, you don't have access to the timestamps themselves, so you don't know which timestamp you're originating from the browser so that you can sync it via data channel at the same time, the best you can do is some best effort kind of thing and trying to implement this on an application level perspective. So ideally, this is something that may be handled when in the WebRTC NV specification. So whenever they work on, let's say, version 2.0 for stuff like this, but not at the moment. Yeah, captioning is a useful use case, but in principle, yeah, it pretty much needs to happen as a best effort thing. So as soon as you have the caption and you're capturing audio, you try to send it exactly as it is, and hopefully it will get there as soon as possible. So there may be some mishap, some delay and so on, but that's the best you can do.
So from someone who just wants to start getting involved and bridging the two technologies together, what would be like the different methods they could do it? I know we kind of discussed it a little bit earlier, but just as what are the different options? Like, just from a straightforward perspective, like what's the best way to do it?
You mean in bridging different technologies, like in Janus and the legacy technology on the other end? Do you mean, or something like getting free switch? No,
just like getting free switch connected to getting free switch connected to Janus, creating like we used for an example like having text channels and that type of stuff. From that perspective, I think most people would want to kind of use a little bit of video, broadcasting. The broadcasting actually seems pretty interesting.
Yeah, in principle, as I was mentioning before, considering that they both speak WebRTC, in theory, it should be just as easy as, let's say, one of the two offering and one of the other answering, and then you get a live stream from one to the other. And so depending on the kind of application that you want to implement, so for instance, if you want to implement an SFU-based conference, but also want this conference to happen on FreeSwitch as well as a mixed video stream instead, ideally this means that for every user that is published on Janus, you also create a related subscriber that is not originated by a real user, but is actually consumed by FreeSwitch as well instead. So that for each participant that contributes to Janus, FreeSwitch also gets a user that is actually sending media to FreeSwitch as well. So that you basically, FreeSwitch acts as a consumer for these streams over here, so that these streams are received by FreeSwitch, all the mixing can happen, and then the resulting mix can then maybe be injected in Janus again as a different publisher, for instance, or possibly even using the streaming plugin in order to turn the resulting mix in a broadcast that you can broadcast using Janus, using the streaming plugin as well, for instance. So it's really just a matter of hooking up these different peer connections and considering WebRTC in standard, and we both implemented the right way, hopefully. So the idea is that these should just work as it is if you just orchestrate the respective APIs accordingly. So you need to know a bit of both worlds, of course. So you need to know how the video mixing works within FreeSwitch in order to, let's say, decide what needs to be added to the mix and what doesn't, how to handle the layouts and stuff like this. And at the same time, how actually different streams need to be handled in the video room in order to take care of different streams, whether or not you need to subscribe to them all, or whether or not they just become options that you can decide to subscribe to. So that even in Janus, you can subscribe to a stream that represents a mix that is coming from FreeSwitch, or to the individual streams that all are available at the same time. So there are really a plethora of options that you can take advantage of if you are familiar enough with both of the different worlds. And this is something that I've noticed that a lot of people that I've spoken to are actually very capable of doing. So I just mentioned Chad and Luca in this case, but there are actually some other very good developers that are actually using FreeSwitch and Janus in production today for very interesting use cases. So I was really surprised at first, but then it actually turned out not to be a surprise at all, because they were just taking advantage of the strength points of both components.
Right. So it's an interesting. So the use case you just mentioned of basically SFU to MCU back out to an SFU and then distribute. What type of what would be what type of distribution can you get out to something like that? Get to hundreds of endpoints? Could you get to thousands of endpoints? What would be the potential of scalability from that perspective?
Yeah, this actually can help in scalability quite a bit, because, for instance, a very simple use case that one could envisage, for instance, is assuming that all WebRTC users are going to just do SFU functionality. So you have a very basic SFU functionality with different windows, different videos sitting around, and so on. You then pass all of these streams to FreeSwitch as well, and then FreeSwitch takes care of mixing all these all together and pushing it to different technologies, like, for instance, you're doing right now, sending it over to YouTube or to other CDNs, or maybe to other platforms that can take care of distributing this even further, and so on. So in this case, it's very easy to have a smaller conversation between a limited number of people using a video relay of sort, and then you push this video these videos to something that can compose them on the fly, and then you distribute them to something that can make them widely available, pretty much as we're doing right now with FreeSwitch, for instance. So the possibilities are really endless, and typically it also makes it really easy to take care of endpoints with different capabilities, because, of course, the ability to do a video SFU and placing windows and videos the way that you want is really cool, but with a mobile device, you will never get able to handle more than one, two, three different streams at the same time, if not at the cost of melting your phone while you're using it. So the idea is that if you can have both, so having your huge mega desktop that can take care of these different streams at the same time, because you have the perfect bandwidth and do whatever you want there, and at the same time take care of a live mixing composition for all of those devices that cannot take advantage of this functionality instead. Maybe either because they don't have the resources, or maybe they don't have the bandwidth to take care of that. And besides, also taking advantage of the fact that you can then very easily distribute these or even record these on the fly in different ways.
Okay, so Len asks, what's the recommended resource size to get started, like CPU, RAM, bandwidth? It's a difficult question to answer, because considering that we conceived Janus to be, let's say, general purpose, this really depends on which plugins you are trying to involve. Because, for instance, the audio MCU is going to take more resources CPU-wise, but a very limited set of resources bandwidth-wise, because it mixes everything and it just creates one-to-one kind of relationships for the media. While the video room instead will use very few CPU, because it's just relaying media around, but it will consume more bandwidth, because the more users you have in a room, and if they are all publishing and all subscribing to each other, the bandwidth consumption increases exponentially, of course, because if you have 10 users, it means that you have 100 peer connections, and sending 1 and receiving 9, and this applies to all of us. So it's very heavy on the server in terms of bandwidth as well. So from the measurements that we did some time ago, it turned out that in principle, if there isn't something that is really CPU heavy, if there isn't any CPU heavy task sitting within Janus itself, the real bottleneck is actually the bandwidth, so the throughput that you can actually get to the machine, rather than the CPU and RAM, which tend to keep quite low in general. And I don't have an exact suggestion for the recommended resource, because in principle you can also install Janus on a Raspberry Pi, for instance. So we tried it some time ago to install it on a Raspberry Pi. We managed to get a video conference between 3 or 4 people with no problem at all. So the idea is that you can scale it down and scale it up as much as you like. So
it's really a matter of playing with it a bit and profiling it to your specific needs, because even the specific application that you want to implement will have a different impact on the resources that you will need. So a simple broadcast will be completely different from a conference, because a broadcast is a one-to-many, a conference is a many-to-many. How many conferences are you going to host on the same server at the same time? What's the bitrate that you're going to involve? There are so many variables at play here that it's a difficult question to answer.
So it was interesting you mentioned using FFmpeg and taking like a legacy device and converting it. I found that really interesting, actually. I haven't heard of anyone doing anything like that before. I guess it's relatively simple, right? But
yeah, no, and for us it's really simple, because it makes it really easy, for instance, at the IETF to just place a static camera over there and a small laptop or a small Raspberry Pi even. We actually use Raspberry Pis at the IETF. We get the video feed via USB on the Raspberry Pi, and an FFmpeg over there captures the video and sends it somewhere. So it's really easy to create out-of-context media streams that then you can broadcast however you want. So.
Right, because coming from, people are crazy about their cameras too. Right?
Yeah.
So from the video production world, people aren't going to want to do real-time production with a webcam, right? Yeah. And so this way they get to use those really high-end cameras with the high-end opticals, and then we just let FFmpeg mess it up.
Yeah, exactly. That's the idea.
Okay, so let's see. Why don't we, tell us a little bit more about, basically, I guess sending RTP outside of the call flow. I mean, that's an interesting concept too. And I guess it's not just the call flow, right?
Yeah, no, exactly. In this case, it's trying to do what the streaming plugin does, but in reverse. So with the streaming plugin, we receive a plain RTP stream out of context, and we turn it into a WebRTC broadcast. And this RTP forwarding functionality tries to do the other thing around. So we receive a WebRTC stream, and then we can take it exactly as it is and push it outside to GStreamer or FFmpeg or something else. And when I mention scalability is because one of the use cases that we used it for is to actually take advantage of this RTP forwarding functionality to actually feed streaming plugins of different Janus instances that are actually in the wild, so that you can create, I don't know, a tree-based topology where you have a Janus instance that is receiving a WebRTC stream as an injection point, and then you have a battery of Janus instances that actually just reflect this video stream to all the viewers that you are interested to serve. So the more viewers you need, you just spawn a new Janus instance, and you just tell the originating Janus instance to forward the media there too. So you just need one copy of the stream to serve a lot of people at the same time. So that's one use case.
Yeah, are you sending additional metadata there, or is it's just the raw streams?
No, it's typically just the raw streams, because then, considering that it is push-based, so the idea is that we just say, send this RTP stream over here. Of course, we need to make sure that there is something over here that is actually receiving the stream. So there needs to be some sort of an orchestration layer on top of that. So it will not just work as it is with just plain Janus, unless you do some manipulation on the Janus API. So the idea is that you have some sort of an overlay, some sort of orchestration layer, a thin orchestration layer, if you will, that just controls the Janus APIs of all the involved components, and then just says, you prepare to receive something on this port, and you send this media to this other guy over here. So apart from this, the communication between the Janus instances is really nothing more than that. It's very lightweight. It's just very loose-based. So just the raw streams, and everything that actually ties them together sits at a different level at the orchestration layer. So you can see the orchestration layer as the brain, and the Janus instances as the stupid arms working in the background for this to work.
You know what I think would be a really interesting use case for this, and I don't know how the implementation, because you can use the APIs, right, to do selective, forwarding, right, and then it could be used for real-time lawful intercept, right?
Yeah. Yeah, that's an idea as well. So this is something that we've actually discussed with some people that we talked to. So this is actually a possibility, something that we didn't implement yet, but in principle, the bricks are all there to implement this if needed, because we have access to the stream, so we can do pretty much whatever we need to do there.
Yeah, because all these, how the regulatory environment is changing so quickly. I mean, being able to provide lawful intercept and that type of stuff becomes a very challenging task overall.
Yeah.
Doing it in a way that it actually doesn't, substantially affect call.
And we're actually using a similar functionality also to capture the streams locally and turn them into, let's say, fake Wireshark traces that we can then analyze. Because, of course, we have a different stack that takes care of the networking and so on. So we just get access to the application level payload, so the RTP packets and the RTCP packets and so on. But if we want to inspect what's wrong, maybe if the browser is sending us a video that is corrupt or something like this, we cannot just do a simple video capture because all of the streams are encrypted. But what we can do is, once it gets to Janus and it is unencrypted, we can save it locally to a text-based file that we can then convert to a Wireshark capture. We inject some fake ports and addresses and so on, and we can analyze the streams using Wireshark, TCP dump, or whatever, in order to analyze the unencrypted payload and figure out if anything that we are putting in the packets is wrong and so on, if anything is confusing the browser for any reason and so on. So this is something that we also implemented recently and proved quite useful for exactly this reason.
Because the other thing is, I mean, you could basically just send it to a Homer server, right? Except for there's no metadata. That's the problem.
Yeah, I mean, you can. The idea is that you can add your own metadata, because typically the component that is actually taking care of the RTP forwarding functionality is always one of the plugins. So, for instance, the SFU plugin is one of the plugins that can actually do RTP forwarding. So once we implement RTP forwarding in there, you can modify the video room plugin to also craft some metadata for you and then send it using any kind of protocol or channel that you see fit for the purpose. So you can imagine a simple curl request in order to push some HTTP request somewhere to say, this stream that I'm sending over here is related to X, Y, and Z. Do whatever you need to do with that. So it's just a matter of manipulating something here, or again, just doing this at an orchestration layer. So you don't let people communicate with Janus directly using the Janus API. You wrap the Janus API yourself in a server, maybe using RabbitMQ or whatever you want to use. You handle users somewhere in a different way, and you just proxy the SDPs and all the connectivity information between the two. And then you have complete control over the Janus API, and you can do whatever you want. You can create your own metadata, exchange it however you want, and so on. And this is actually a common scenario that most people are following when deploying Janus in production.
So can you explain compatibility between Janus and Verto?
Yeah, I must admit I'm not really familiar with the Verto protocol by itself, but as far as I know, it's actually JSON-based as well. So, the idea is that the Janus API is just as JSON-based as itself, so it's really quite simple to set up and so on. So, in principle, if the purpose of both of them is eventually to establish peer connections between two different endpoints and so on, it should be quite easy to have to bridge them into from an application layer. So you can assume a very simple application server that is sitting on the server side that talks both Verto to talk to FreeSwitch and the Janus API to talk to Janus, and then orchestrates these calls in order to have something happen between the two. So for instance, create a call on FreeSwitch, create a call on the Janus API, and basically act as a third-party call control, but not using SIP at all, but using two very different protocols and just bridging the signaling information across the two. And then eventually they just create a peer connection between each other, which again is the beauty of using standards in this case. So no matter how different the protocols are, we are still both using SDP for the purpose. We are both still using the same way of exchanging candidates and so on. And so eventually all just works as expected.
So one of the things one of the questions that I get a lot is, and it's relatively easy. It's relatively easy, but doing more complicated things. So the calls, you have a couple people in a video bridge, right? And then all of a sudden you have to dial out to the PSN. And so you have the plugin that does the interconnect, right, via SIP. But then all of a sudden you can send it through the FreeSwitch LCR and that type of stuff. So can you talk about that a little bit? Like how would someone out there, achieve something like that? Maybe from an origination or termination standpoint. So it's about merging the RTC technologies together with legacy technologies.
Yeah, the way that we typically handle it, and one use case is actually the IETF example that I showed before, is to try and use some, if you're just using Janus, to use some sort of hybrid kind of approach. So for instance, the very easy way that we went with at the IETF was to stick with SIP for audio and just use the WebRTC for video. So which is why we are using the SIP plugin to connect to a SIP server that takes care of the audio mixing there. And then all the video is instead relayed exactly as it is, whether it comes from the streaming plugin or the video room plugin and so on. And this makes for a very easy way to let's say, still allow PSTN users to communicate, or even SIP users to communicate, even though only limited to audio for what concerns talking to each other. But then if you want video, you have to just stick with the browser or an ad hoc mobile app and so on. Which is where actually FreeSwitch comes in handy, because in that case, as we were saying before, you can actually have video involved as well in the process, because you don't have to just mix audio. You can also mix video if you want and keep the different streams at the same time, if you're just connecting to Janus for that. So there are different ways to tackle that, and the easiest way is just to say stick to audio for SIP users and PSTN users, and use video just for WebRTC participants. And when you want to try and make things more complicated, you start to try and involving Janus and FreeSwitch together, as we were discussing before. So trying to forward the streams back and forth, trying to, of course, orchestrate this accordingly so that you don't have duplication of video streams in any of the two components and so on. So it takes a bit of magic and orchestration, but nothing that somebody proficient in both of the components cannot do.
Okay, well, thank you for coming in today. And I look forward to seeing you next week, right?
Thank you for having me here. It was really nice chatting with you guys.
Yeah, back to you.
All right, cool. Thank you very much, guys. Lorenzo, thank you very much for joining us today. Michael, Mavridis, thank you guys very much. Thank you for coming in and speaking with Lorenzo. Let me get myself back on camera here. And what we're going to do here is, for you guys that are in Europe, are looking to make that trip to Europe, and you've already got your tickets to ComCon, you guys look for, let's see here, Mavridis, Lorenzo, and Michael Jarris there next week. They're going to be hanging out, doing some presentations, and getting to visit with everybody. Don't forget, as Josh said earlier, ClueCon's coming up rapidly. There's about 10 days left. If you haven't got your hotel reservations and you want the discount from the hotel, you need to go and book your hotel room now. Watch the earlier part of the video and get that discount code again, because there's only a limited amount of time left on it. ClueCon just around the corner, guys. Thanks, and we'll see you next week.
You've been watching ClueCon Weekly. Tune in every Wednesday at 12 p.m. Central. Keep up with the latest happenings by subscribing to our YouTube channel, follow us on Facebook and Twitter, or visit us at freeswitch.com.